You are sitting in the service waiting room, and the service advisor looks you dead in the eye and tells you that your automatic transmission fluid is a lifetime fluid and never actually needs to be changed. That is without a doubt one of the biggest mechanical lies circulating in the automotive industry today. When a dealership tells you a fluid is lifetime, they strictly mean it is designed to last for the lifetime of the factory powertrain warranty. Once that short warranty window expires, the heavy sludge, friction material, and varnish building up inside your transmission pan right now is going to permanently clog the internal valve body, stick the sensitive shift solenoids, and leave you stranded with a massive rebuild bill. You absolutely do not want to hook your high-mileage vehicle up to a high-pressure transmission flush machine, which can violently shock the system and dislodge catastrophic debris into the narrow hydraulic passageways. What you actually need to do is a safe, simple, partial drain and fill. By just pulling the drain plug, letting the few quarts of fluid sitting in the pan naturally drip out, and topping it off with exact factory spec fresh fluid a few times over the course of a couple of weeks, you safely refresh the hydraulic system. This gradual process replaces almost all of the old fluid without breaking loose any dangerous gunk. Your gear shifts will go back to feeling incredibly crisp, and you will save your transmission from an early grave. Before we get into the exact underhood fluid you are probably completely neglecting right now, and how to fix it for basically free in your own driveway, if you want to keep your daily driver out of the expensive repair shops, hit that subscribe button right now to join the garage. Let us talk about a critical fluid that you physically rely on every single time you turn the steering wheel, yet almost no one services it until the power steering pump starts aggressively whining and screaming. Power steering fluid goes through brutal thermal heat cycles, it oxidizes, turns highly acidic over the miles, and fills up with microscopic metal shavings generated from the internal pump wear. This dark, nasty fluid actively eats away at your expensive steering rack seals from the inside out. You do not need thousands of dollars in shop equipment to fix this. Go to the kitchen, grab a clean turkey baster, or buy a large fluid syringe from the auto parts store. When the engine is stone cold and turned off, suck as much of that old dark fluid out of the power steering reservoir as possible. Top it off with fresh fluid right up to the maximum fill line. Start the engine, slowly turn the steering wheel, all the way from lock to lock about 5 times to bleed the system, shut the engine off, and do the baster trick one more time. Just 2 cycles of this completely basic method will safely swap out about 70 to 80% of the degraded fluid in your system. Doing this simple maintenance will massively extend the life of your expensive steering rack and keep the wheel feeling light and responsive. While you are under the hood doing basic maintenance, let us look at why your car might be violently vibrating at stoplights. So many drivers blindly throw expensive parts at a rough idle, buying brand new spark plugs and ignition coils, when the actual problem is just a thick buildup of oily carbon right on the throttle body flap. The throttle body is the mechanical gatekeeper that controls the exact amount of air entering your engine. Over time, hot crankcase vapors coat the inside of the aluminum housing with a sticky black sludge. This sludge physically prevents the internal butterfly valve from closing properly, confusing the engine computer and causing your idle RPMs to constantly bounce up and down or completely stall out. Grabbing a cheap can of dedicated throttle body cleaner and a clean microfiber rag, and just wiping that metal flap down until the aluminum shines again, will instantly smooth out your rough idle and make your throttle response feel incredibly sharp the second you step on the gas pedal. Right next to that throttle body is the absolute most critical sensor for your fuel economy, the mass airflow sensor, commonly known as the MAF. This little electronic component measures exactly how much air is entering the intake tract so the main computer can inject the perfect, mathematically precise amount of fuel into the cylinders. Over tens of thousands of miles, microscopic dust particles slip past your engine air filter and bake directly onto the incredibly delicate hot wire hidden inside the MAF sensor housing. When that wire gets coated in dirt, the sensor starts reading low. Your engine thinks it is getting significantly less air than it actually is, causing the computer to dump raw fuel to compensate. The engine runs excessively rich, wasting expensive gasoline and completely fouling out your spark plugs with heavy black soot. You need to carefully unplug and remove this sensor and spray it down exclusively with a dedicated MAF sensor cleaner. You must never use brake cleaner or carburetor cleaner on this part, as those highly aggressive chemical solvents will melt the plastic housing and instantly destroy the sensitive electronics inside. Just give the hot wire a few quick sprays, let the sensor air dry completely for about 10 minutes, and bolt it back into the intake tube. You will immediately notice a much stronger mid-range pull when accelerating and significantly better MPG on the highway. Speaking of how your engine burns fuel, let us talk about your fuel injector. Over the years, the microscopic spray holes at the tips of your fuel injectors get heavily coated in a rock-hard varnish from running cheap, low-tier gasoline, Instead of spraying a perfect, highly atomized mist of fuel into the hot combustion chamber, a heavily clogged injector will just aggressively drip or squirt raw liquid gas. This completely kills your acceleration, causes severe random cylinder misfires, and makes the entire engine block shake. Forget those cheap little $3 bottles of additive you pour into the gas tank. They are just weak solvents that cannot touch baked-on carbon. To really melt that carbon away, a professional cleaning procedure involves disconnecting the main fuel rail and running the engine on a highly concentrated, direct injector cleaning solution for about 5 minutes straight from a pressurized canister. You then turn the engine off and let the harsh chemicals hot soak into the internal engine deposits for 10 minutes. When you start the car back up, it is going to blow a massive, nasty cloud of smoke out the tailpipe as it actively burns off all that dissolved carbon. But immediately after that clears, the engine will run as smooth as glass. But what actually causes all that nasty oil sludge and carbon buildup in the intake tract in the first place? It is usually a completely forgotten $5 plastic piece called the PCV valve. The positive crankcase ventilation valve is specifically designed to route harmful, highly pressurized blow-by combustion gases out of the engine block and route them back into the intake manifold to be safely burned off. When this little spring-loaded valve gets completely clogged with old, neglected oil sludge, that massive internal engine pressure has absolutely nowhere to go. It will physically push out your main engine seals, causing massive oil leaks all over your driveway, and it will forcefully blow raw liquid oil straight up into your intake manifold. Swapping out a rattling old PCV valve for a brand new factory replacement takes about 2 minutes, costs less than a fast food meal, and literally saves your engine from blowing out its own expensive internal gasket. We are about to get into the absolute biggest mechanical mistakes people make when they try to modify their cars for more horsepower, and why a bad performance tune will completely destroy your engine block. But before we get to that critical warning, if you are learning something new and want to keep your project build running strong, hit that subscribe button right now. Let us talk about unlocking the real power your vehicle is hiding. Automotive manufacturers deliberately detune their engines straight from the factory floor. They intentionally program the engine control unit incredibly conservatively so the motor can survive on terrible quality gasoline, endure completely neglected maintenance by lazy owners, and fit into a very specific horsepower and torque hierarchy in their dealership lineup. A proper Stage 1 software tune completely changes the game without you having to turn a single wrench on a physical mechanical part. A professional tune rewrites the ignition timing maps, optimizes the turbocharger boost pressure to push more air, and leans out the overly rich, sluggish factory air-fuel mixture for pure performance. It pulls your engine out of survival mode and unleashes its true mechanical efficiency. It is not uncommon to see an easy 50 HP and 50 pound-feet of torque gained on a modern turbocharged engine just from software. But to safely run this much power without melting a piston, you absolutely must maintain the car perfectly, using high-quality full synthetic motor oil and strictly pumping 93-octane premium fuel at the gas station to prevent catastrophic engine detonation. However, if you are going to push your engine past the safe factory limits, you have to actively avoid some massive amateur mistakes that plague the car tuning community. The very first mistake is trying to run a high-performance aggressive tune on old, broken-down motor oil and cheap regular 87-octane gas. Pushing higher boost pressures and advanced timing on a neglected, poorly lubricated engine is just begging for a thrown connecting rod to punch a hole right through your engine block. The second massive mistake is ripping out your highly engineered factory airbox to install a cheap, unshielded, open-element cone air filter right above the blistering hot exhaust manifold. You are basically building a hot air intake. Your engine will suck in that superheated underhood air, drastically increasing intake air temperatures. When the computer sees that blazing hot air, it will heavily pull ignition timing to save the engine from knocking, resulting in a massive loss of horsepower. You actually make the car slower. The third massive mistake is treating your engine bay like a playground and yanking out vacuum lines, intake resonators, or sensor connections just because you mistakenly think they are restricting your airflow. Modern engines are highly complex, perfectly balanced ecosystems. Removing random vacuum lines will immediately trigger a massive unmetered air leak, force your car into a restricted limp mode, and light up your dashboard with a check engine light. Respect the heavy engineering, do your preventative maintenance, and modify your car the right way. It all comes down to fundamentally understanding how your specific machine actually breathes, shifts, and manages heat, instead of blindly trusting the lifetime fluid marketing lies or ripping out factory parts you do not fully understand. Keep your transmission and steering fluids fresh, clean your crucial mass airflow sensors, swap out that dead PCV valve, and if you are going to tune your daily driver, do it responsibly with the exact right octane fuel. Now I want to hear from you. What is the absolute worst, most frustrating check engine light code you have ever had to chase down in your garage? Or what specific rough idle or shifting problem is your car suffering from right now? Drop your exact symptoms, your engine type, and your OBD2 scanner codes down in the comments below, and let us figure it out together. And if you have not already, hit that subscribe button, give the video a solid like, and I will see you in the next one.